In this question, it is given that let a tangent to the curve 9x square plus 16y square equal to 144 intersect the coordinate axis at the points A and B. Then the minimum length of the line segment AB is dash. You have to fill in the blank. It's clear that the equation of curve this can be written as x square by 16 plus y square by 9 equal to 1. That is, clearly it is representing a ellipse with a equal to 4 and b equal to 3, and it is given that a tangent is drawn to this ellipse and it cuts the coordinate axis at a and b. You have to find the minimum length of the line segment AB. You know that any point on this ellipse can be taken as 4 cos theta, 3 sin theta. Clearly the equation of tangent at this point will be x into cos theta by 4 plus y sin theta by 3 equal to 1. That is, I can say the point A is 4 sec theta, 0, and the point B will be 0, 3 cosec theta. Hence, AB becomes under root 4 sec theta whole square plus 3 cosec theta whole square. To find the minimum value of AB, I will find the minimum value of inside portion. Once the minimum value of inside portion is known, the minimum value of AB will be known to us. This can be written as 16 secant theta plus 9 cosecant square theta. The smart way of doing this question is write this as 1 plus tan square theta, write this as 1 plus cot square theta. I'll get 16 into 1 plus tan square theta plus 9 into 1 plus cot square theta. That is 25 plus 16 tan square theta plus 9 cot square theta. And using the concept of arithmetic mean greater than equal to geometric mean, I can easily say that 16 tan square theta plus 9 cot square theta by 2 is clearly greater than equal to 16 tan square theta into 9 cot square theta. That is, I will get 16 tan square theta plus 9 cot square theta is greater than equal to 24. Hence, the minimum value of this I have got is 24. Therefore, the minimum value of this whole becomes 49. That is, we have got the minimum value of this as 49. Therefore, the minimum value of this whole becomes 7. Hence, I can say answer to this question is 7. And those students who are not being able to think about the concept of AM greater than equal to GM, the other way of doing this question is let tan square theta equal to T, and therefore this expression can be written as, say, L equal to 16T plus 9 by T, and T is clearly greater than 0. Therefore, dl by dt will be 16 minus 9 by t square. Putting it equal 0, I get the value of t as 3 by 4. Clearly, for T equal to 3 by 4, the value of L will be minimum. It is not difficult to check. Hence the value of L for T equal to 3 by 4 is 16 into 3 by 4 plus 9 into 4 by 3. That is the value of L is 12 plus 12, that is 24. Therefore, I can say the minimum value of this is 24. Hence, the minimum value of this whole is 49, and therefore the minimum value of AB becomes 7.